Hey everyone, welcome to Unit 13, Lesson 1, Intro to Graphing Quadratics. So in Unit 12, we learned how to solve quadratics, whether that was by taking square roots, factoring, quadratic formula, something like that. So quadratics are any type of equation in which we have an x squared term in there. Now, if you think about what we've done mathematically earlier in this course, when we learned about linear equations, something that looked like y equals 2x plus 5, we first started with problems and how to solve them. Like if I had 2x plus 5 equals 11, we learned how to solve that first and to get x by itself. Then we learned eventually how to graph those. Well, that same concept is coming through here. Unit 12 was how do we solve quadratics, something that looked like x squared plus 5x plus 10 equals 0. Now we're going to learn how do I graph this equation or equations that look like this. So that's our goal for today. Now, an important thing is whenever we want to graph a quadratic equation, it needs to be in standard form. So remember, standard form looks like this. Y equals ax squared plus bx plus c. In other words, the x squared term has to come first, the x term has to come second, and then the constant, the number without a variable, is last. That's the order we want those in. So remember, a, b, and c are just numbers. So this could be anything like 2x squared plus 5x plus 30 or anything, right? A, b, and c are just numbers. So when something is in standard form, we can graph it appropriately, taking steps that we will learn later on. But just like when we learned quadratic formula, it's important to know what our a, b, and c values are as we go through the process. So a little bit of vocabulary when it comes to the graphs of quadratics. First and foremost, the graph of a quadratic is something that we call a parabola. Okay, we could see that word there, a parabola. And it's kind of just basically this U shape, okay, where it can be going down, back to up. That's a parabola. Or it can be starting by going up and then come back down. Okay, so that's what a parabola looks like. Now, you'll see this word vertex in the picture. The vertex is the point at which the graph changes direction. So we can see in this first one, the graph started by going downward, and then it hits this vertex right here at the bottom, and then everything after that vertex, it's now going upward. So the vertex is where the graph changed direction. Likewise, in the second one, the graph was originally going upward, then it hits this vertex right up here at the top, and then everything after the vertex we can see was heading downward. So the point where the parabola changes direction is the vertex. Now the vertex is also like the highest point of a graph or the lowest, depending on whether that U shape is going upward or downward. So in this first one, we see the vertex is the lowest point of the graph. And in the second one, the vertex is the highest point of the graph. Lastly, parabolas have something called the axis of symmetry. Now, the axis of symmetry is the line that basically cuts the parabola perfectly in half. That line of symmetry is always going to go through the vertex. So we can see in this first case, the axis of symmetry is right here. It's going perfectly through the vertex, and the left side is the exact same as the right side. If we were to fold this parabola, it would land perfectly on top of itself. Okay, likewise here, this vertex straight up and down through the vertex, that axis of symmetry, and we get the exact same thing on both sides. Okay? So, a couple other pieces about each of these. First, the vertex. As I mentioned earlier, if the graph is opening upward, so it's a regular U shape, the vertex is the lowest point on that graph. We call that a minimum. Okay, the lowest point on a graph is called the minimum. It's the smallest it could be. Whereas if the graph is opening downward, so that's one that looks like this, kind of that frowny face, then the vertex is going to be the highest point. We call that a maximum. It's the largest possible value. Now, we have some pretty simple equations that we can use in order to figure out the coordinates of the vertex. Remember, our ultimate goal is to graph these, so you'll see some examples here at the end. Okay, we have graphs that we want to draw these parabolas on. So what we want to do is we want to figure out points that are on the parabola, and then we end up connecting them in the end. So in order to find the x-coordinate of the vertex, okay, so we're looking right here now. To find the x-coordinate of the vertex, we use this equation. X, which is the value we're looking for, is equal to negative b over 2a. Now, where are b and a coming from? That equation that they give us that we're ultimately trying to graph. So we'll see that in a little bit. Okay? Now, we have to find x first. This is one of the nuances of graphing quadratics. We have to find x first, because in order to figure out what y is, we use the x value. So to find the y coordinate, we plug that x value in to the equation, and then whatever that number ends up becoming after we plug x in, that's the y value of the vertex. Okay? So let's take a look at an example here. Find the vertex of y equals 2x squared minus 4x plus 8. First thing we want to do, like we've been doing with our quadratic formula, is identify our a, b, and c values. So here we can see a is 2, b is negative 4, c is positive 8. So using this equation right here, x equals negative b over 2a. X equals negative b over 2a. Now, if I plug these in, negative b, my b value is negative 4 over 2 times a, which is just 2. Now, another way we can think about this negative here in front of the b, or here if we look at the general formula, is the opposite of b. So in other words, if my b value was negative 4, the opposite of that is positive 4. Mathematically, that's what ends up happening here. If I have negative 4, two negatives become a positive. So this becomes positive 4 on top. It's the opposite of b. And then on bottom, 2 times 2 is 4. And this ends up simplifying. 4 divided by 4 is 1. So what that means is this. The vertex of the parabola, the highest point or the lowest point, that point where it changes direction, the x-coordinate on our graph is going to be 1. Now, in order to find the y-coordinate, now we go to this step right here. In order to find the y-coordinate, we plug that x value of 1 back into the original equation. Y equals, so now I'm going to take this part right here, and I'm going to copy it, but instead of writing x's, I'm going to plug 1's in. So it's going to be 2 parenthesis 1 parenthesis squared. I replaced the x with a 1, minus 4 parenthesis 1 instead of the x, plus 8. Now, some may be thinking, are the parentheses necessary? Are they important? And the answer is yes, they are necessary. It is so important that you remember to put parentheses around whatever you're plugging in, because it ends up affecting our order of operations when we do our calculations. Now, at this point, if you want to try to do something like this by hand, by all means you can, but the safest and most secure way to make sure that you're getting the correct value is to type this into the calculator. So, notice we have two, let's see if I can get a split screen here for us. There we go. So, I'm going to type this part right here directly into the calculator exactly as it is. So it's going to be over here 2 parenthesis 1 parenthesis squared minus 4 parenthesis 1 close the parenthesis plus 8. And we can see that in the end my final answer is 6. So that's the y value of the vertex. The y value is 6. Therefore, the vertex is located at the coordinate 1, 6. Okay. Now, this process took a little bit. I promise it's going to get a lot faster the more examples we do, but that first one, I think it's just so important to make sure we take the time and explain each step thoroughly. So again, one more time walking through. When we're given the equation, we label our a, b, and c. We start by finding the x value by plugging it into the formula negative b over 2a, the opposite of b over 2a. After we plug those in and simplify, we get our x value. That's the first half of our answer. We take that x value then and we plug it back into the original equation in place of x and solve to get our y value. In this case, it was 6, so our vertex is at 1, 6. Okay. If you're still feeling confused, okay, one thing you can do is obviously rewind, watch again, try to make more sense of it as we go. But if you're ready to move forward, we're going to proceed with the notes. Okay, the axis of symmetry, which again, if you can recall, was just that line that goes up and down through the vertex and through the middle of the parabola. Okay. It's always going to be going through the vertex, as we mentioned, and it's a vertical line. So its equation is always going to be written as x equals a number. Okay. Now, what is that number that it's equal to? Very easy. Okay. This number will be the same as whatever the x-coordinate is of the vertex. So when we do that negative b over 2a, that gives us the x value. The axis of symmetry, or the equation of that vertical line, is going to be x equals whatever that number is. So in this case here, if the vertex is at 3, 2, what is the equation of the axis of symmetry? Well, as we just mentioned, the equation of the axis of symmetry is going to be x equals a number. What is that number? It's whatever the x-coordinate of the vertex is. Well, the x-coordinate of the vertex is 3. So x equals 3 is the equation for the axis of symmetry. It's the vertical line at 3. Okay. Now, last set of rules here before we start doing our graphing. How do we determine whether the graph is opening up or down? In other words, if it's up, that's our smiley face. If it's opening down, that's our frowny face. So how do we know which direction it's going? It's actually very, very simple. Okay, and the reason I'm using smiley face and frowny face is because I think it makes a really nice personal connection. If A, so that number out in front, if A is positive, the graph will open upward. So an example of that, if it's y equals 4x squared minus 6x plus 9, the graph will open upward because the A value is positive. Easy way to remember this. If you are a positive person, if you're in a positive mindset, you're probably going to be smiling. You're going to be happy. So a positive A value will produce a parabola that opens upward. It's going to give you that smile face look. However, what if that A value is negative? Okay. If A is negative, then the graph will open downward. So in this case here, the A value is -2. It's a negative coefficient, so it's going to be a downward parabola. Okay, and same thing, if you're feeling negative about something, you're probably not going to be smiling. So that's a frowny face as a way to help maybe remember that. Okay, so a quick answer to a question like this example. Does y equal -3x squared plus 4x minus 7 open up or down? We don't even have to graph it to know what that answer is. All we have to do is, if I want to know, is this graph opening up or down, I look at this A value. The A value is -3. So since A is negative, the graph opens down. Okay, very straightforward. Positive, smile, up. Negative, frown, down. Okay, so a lot of good important stuff here that leads us into how do we actually graph. We find the vertex, axis of symmetry. Should my graph be opening up or down? Okay, what are the actual steps to graphing. Okay, first and foremost, we want to make sure that the graph is in standard form. Y equals ax squared plus bx plus c. If it's not in standard form, we can't graph it yet. Next thing we want to do, we find the vertex. Okay, we talked about that a couple slides ago. That's where we find the x value first using negative b over 2a. Plug that x value back into the equation to find y. Now, after that, we're going to choose two x values to the left of the vertex, plug them in to find the y values, and we could plot those points. Then we could choose two x values to the right of the vertex, plug those in, and get those 2 points, and then draw a smooth curve through the points. Now, I'm actually going to show a little bit of a shortcut as to how we can make this process a little bit faster. Okay, so let's take a look at our first example. Graph y equals x squared minus 4x minus 3 using a table. So, first thing I'm going to do, I'm going to identify, is it in standard form? And it is. The x squared comes first, the x comes second, the constant comes third. Next thing I want to do is I want to find the vertex. So, I label a is 1, b is negative 4, c is negative 3. In order to find the vertex, I start by using my x equals negative b over 2a. Okay, and I'm not always going to write out the negative b over 2a every time. So negative b, the opposite of b. b is negative 4, so the opposite of that is positive 4. 2a, well, a is 1, 2 times 1 is 1. I'm sorry, 2 times 1 is 2. So 4 divided by 2 is 2. This means that the vertex is at 2 comma something. Well, what is that something? We take that 2 and we plug it back into the original equation up here. So instead of saying x squared to start, it's going to be 2 in parentheses squared minus 4 in parentheses 2 minus 3, and we'll see what that equals. So over on the calculator side here, 2 in parentheses squared minus 4 parentheses times 2 minus 3, and we can see that we get negative 7. So the y value of the vertex is at negative 7. So vertex is at 2, negative 7. Now, even though these two parts aren't necessarily essential to graphing, it is important to kind of understand what our graph should look like. So what direction is it opening? My a value is 1. It's positive. So my graph should be opening up. And I'll check this at the very end. But if all things are done correctly, the graph should be opening up. As far as the axis of symmetry goes, remember we talked about that earlier. The axis of symmetry is x equals a number. That number is whatever the x-coordinate of the vertex was. So x equals, and my x-coordinate is this 2 right here. So x equals 2 is the axis of symmetry. Now, what we found is 1 point on the graph, 2, negative 7. So that's 2 to the right, down 7. 1, 2, 3, 4, 5, 6, 7, right there. Okay. Now, from here, where do the rest of the points come from? Remember, I want that U shape, the smile or the frown. Where do these other points come from? That's where the table comes in handy. So on our table, the left side is always going to be our x coordinates. The right side is always going to be the y coordinates. Now, from here, what I'm going to start with is by taking that vertex we found, this 2, negative 7, and I'm going to put that in the middle of my table. I'm going to put the 2 right there for the x, the negative 7 on the right side underneath y. And the reason I put it in the middle is because this vertex is ultimately going to be in the middle of my graph. What I want to find are 2 points over here on the left side, 2 points over here on the right side. So the way we do that is I think about what two numbers, like on a number line, what two numbers would be to the left of 2, what two numbers would be to the right of 2. So if I think about a number line and I'm thinking about the number 2, the first number to the left is 1. The second number to the left is 0. And when I think about the number 2, the next number to the right of it is 3. And then the number next to that is obviously 4. Okay? So what we do now is we're going to take these x values, 1, 2, 3, 0, 1, we already know 2, 3, and 4, and we're going to plug them in to the original equation to figure out what y coordinate goes with each of those x's. And what we're actually going to do is a little bit of a shortcut along the way. So in this first one, x is 0. If x is 0, what's the y value? Well, the way we do that is I take this original equation and I plug 0 in. 0 squared minus 4 times 0 minus 3 equals. Now, anytime you're working with 0, you shouldn't need to use your calculator. 0 squared is obviously 0. Minus 4 times 0 is 0. So anytime we have 0, the first two terms don't mean anything. It's going to be 0 minus 0, which is still 0, minus 3. I'm just left with negative 3. In other words, when x is 0 for this graph, the y value is going to be negative 3. Now, if I plot that point, 0 means I don't go side to side, negative 3 means I go down 3. There's actually a second point I can get right away. If you remember, with this whole idea of an axis of symmetry, any point that's over here on the left side, it's got a mirror image over on the right side. Okay, likewise, if I have a point here, straight across, I've got a mirror image right on the other side. So what that means is this. If 0 is at negative 3, then that means this 4 is also going to be at negative 3. Okay, and I can prove it very, very quickly. If I were to type this red equation into the calculator but replace the zeros with 4s, parenthesis 4, close the parenthesis, squared, minus 4, parenthesis 4, close that, minus 3. Sure enough, you can see it's negative 3 again. This is a really nice shortcut that you can use based on the concept of symmetry. If I know the number on the left, I can transfer it over to the right. So 4, negative 3 is also on the graph. 1, 2, 3, 4, negative 3. 1, 2, 3. Okay, so we have those. Now lastly, what about 1 and 3? These two answers are going to be the exact same number. Okay, so what I'm going to ask myself is which number is easier to work with, 1 or 3? In my opinion, the answer is 1. So what I'm going to do is I'm going to do this same equation, the original equation, but I'm going to plug 1 in instead. So using again one more time this equation, parenthesis 1 squared minus 4 times 1 minus 3. Okay. And again, I can type that in pretty quickly here. Parenthesis 1 squared minus 4, parenthesis 1, minus 3, and I get negative 6. Therefore, 1 leads me to negative 6. 3 will also lead me to negative 6 due to that symmetry. So if I plot 1, negative 6, that's 1 to the right, down 6, and then 3, negative 6. And those are my points, and you can see it's now starting to create that curve shape. Only other thing we have to do is draw this smooth curve that goes through both points. So I'll start at the vertex and go up to the left, start at the vertex, go up to the right, and there's our final answer. Okay. Now again, first time ever doing a problem like this, it's going to take longer than it normally will. The more examples we do together and the more examples you do on your own, the faster this whole process is going to be. Okay, so let's take a look at another one. We want to graph negative 2x squared plus 12x minus 13. Okay, first question, what direction is it opening? Hopefully we see that since a value is negative, it is opening downward. Okay, axis of symmetry and vertex, we'll get back to those in a second. Is the vertex a maximum or a minimum? Well, if the graph is opening downward, then the vertex is obviously going to be the highest point on the graph. It's going to be a maximum. Okay, so how do we fill out these other two questions then, the axis of symmetry and the vertex? Well, in order to know the axis of symmetry, again, we have to find the vertex. The vertex is the opposite of b over 2a. So a is negative 2, b is 12, c is negative 13. So opposite of b, opposite of 12, is negative 12, over 2 times a. A is negative 2. So negative 12 on top, 2 times negative 2 is negative 4 on bottom. Negative 12 divided by negative 4 is positive 3. Therefore, my vertex is at 3 something, and my axis of symmetry is at x equals 3. Now, lastly, I have to find the vertex y-coordinate. So again, the way we do that, y equals, and I'm going to rewrite the original equation, but I'm plugging 3 in for x. Negative 2 times 3 squared plus 12 times 3 minus 13, and this is what I'm definitely going to use my calculator on. Negative 2 parenthesis 3 squared plus 12 parenthesis 3 minus 13, and y equals 5. So that is my y-coordinate. The vertex is located at 3, 5. So my x, y, again I put 3 and 5 in the middle of my table. Okay, I can also graph 3, 5, which is 3 to the right, 5 up, 1, 2, 3, 4, 5. And there's my vertex. Now, I need 2 points to the left, I need 2 points to the right. So I think about my number line. If I'm thinking about the number 3, the next number to the left of it is 2. The number to the left of that is 1. When I think about to the right of 3, it's 4 and it's 5. From here, I'm going to pick the two easiest numbers to work with, which in my opinion are going to be the 1 and the 2. So in order to figure out what 1 gets paired with, I plug 1 into the original equation. So when I plug 1 into the original equation, I'll do this over here. Negative 2 times 1 squared plus 12 times 1 minus 13. When we do that, oh, this saves a lot of time. Did not know I could do this. Okay, so on your calculator, you can just go back and retype, but replacing new numbers inside the parentheses, and we can see that when we do that, we get negative 3. So that means when we plug 1 in, the y value that corresponds to it is negative 3. Using the idea of symmetry, this 5 will also go to negative 3. So 1, negative 3 is 1 to the right, 3 down. And then we had 5, negative 3. 5 to the right, 1, 2, 3, 4, 5, down 3 right there. Okay, now the last ones we need to do. Where are 2 and 4 taking us? So 2, same thing. I would just do negative 2 times 2 squared plus 12 times 2 minus 13. I'm going to use my calculator shortcut and replace the 1s with 2s. And I can see that it's positive 3. So 2 led me to positive 3. 4 will also lead me to positive 3. So I need to plot the points 2, 3, and 4, 3. 2, 3, 4, 3. And again, we see that frowny face now, which is what we expected from the very beginning. It's a downward, starting at the vertex, going through there. Okay, and there's our downward parabola. Okay, notice the second one went a lot faster than the first one. So, last example here. Okay, if at any point you want to try going at your own speed, go ahead and do that. If you want more support and just continue to watch, totally fine as well. If you do try to go ahead, what I would remind you of, be very careful. Think about there's no x value, so what would that b value be? Okay, so let's talk. First one, what direction is this graph opening? Y equals negative x squared plus 6. Well, we see this negative sign right in front, so this is going to open downward. Okay, axis of symmetry and vertex. Well, we'll get back to those. Is the vertex a max or a min? Again, if the graph is opening downward, the vertex is going to be the highest point. It's a max. Last two things, vertex and axis of symmetry. So again, vertex, x equals the opposite of b over 2a. So let's figure out what those numbers are. In the original equation, a is negative 1. There is no x term. There isn't one, which means there is no b value. Okay, b is 0. Lastly, c is going to be positive 6. So when we plug those in, the opposite of b, the opposite of 0, well, we wouldn't say negative 0. There's no such thing as negative 0. So this is that one case where we just leave it alone. 0 on top. 2 times a, which is negative 1. So that's 0 divided by negative 2. Well, 0 divided by anything stays as 0. So the x-coordinate of the vertex is 0. The axis of symmetry is x equals 0. Now, as far as the y-coordinate goes, y equals, we plug in the 0 we just found, negative, parenthesis, 0 squared plus 6. Okay, 0 squared is 0. If we make it negative, it's still 0. Really, this whole term would just be gone, and we're left with plus 6. But just to verify that for you, negative, parenthesis, 0 squared plus 6 comes out to be 6. So that is our y value. The vertex is at 0, 6. So I'm not going to move left or right at all, but I'm going to go up 6. 1, 2, 3, 4, 5, 6. And I'm going to plot that point. Okay. Now, in order to find the other points, we go back to the table. X, y. I'm putting 0, 6 right in the middle. 0, 6 right in the middle. Now, if I think about a number line, what would be to the left of 0? It would be negative 1 and negative 2. What would be to the right of 0? Be positive 1, positive 2. Okay. And now, same thing as before. Now, when I look at my table, I could use this negative 2. I could use this negative 1. I could use the positive 2. I can use the positive 1. I can pick whichever ones I want to use. Me personally, I always like to use positive numbers when I have the chance. So I'm going to find out, what does this 1 give me? What does that 1 give me? So I'm going to plug the 1 into the original equation. Negative, parenthesis, 1 squared plus 6. If I go over to my calculator, replace that 0 with a 1, and I see that it is 5. 1 squared is 1. Then I apply the negative to make it negative 1. Plus 6 is 5. So that means at positive 1, it's 5. And using symmetry, at negative 1, it'll also be 5. So 1 to the right, 5 up. 1 to the left, 5 up. And then lastly, what about 2? Where does 2 bring us? I'll replace that 1 with a 2, and I can see that when we plug 2 into the equation, the final answer is also 2. So negative, parenthesis, 2 squared plus 6 is 2. So that means 2 gives us 2, negative 2 also gives us 2. So I'll plot the point 2, 2, plot the point negative 2, 2, and then the last step is to draw the curve that goes through the points. And as we mentioned, this would be a downward facing parabola, which it ended up becoming. Okay? So a lot of stuff in today's lesson. Okay? Over the course of this week, we're going to ask that you practice these. There's a homework assignment as well as an additional activity as well that gives a lot of practice with graphing. So again, make sure you remember those steps. Finding the vertex. Once you find the vertex, pick 2 numbers to the left and 2 numbers to the right of the vertex, and use symmetry to really cut down the amount of work you need to do. Okay? If at any point you are feeling lost or confused, as always, you can rewind the video and rewatch this as many times as you need, or you can drop by the Google Hangouts that we are conducting, or as always, feel free to shoot me a message in Schoology or an email, and I will be more than happy to assist you in any way that I can. Okay? So thank you guys for watching. I hope all is well with you and your families, and until next time, take